And now it's time to present the speakers from the Bulgarian language industry. The first one is Lachezar Dzhakov from the company Skycode, who is going to present neural networks in market-ready Bulgarian text-to-speech. Lacho, the floor is yours.
Thank you, Sveta. So let me share my screen.
Very nice to see you.
Nice to see you all. I'm going to talk about a project we've recently implemented, and it's a market-ready Bulgarian text-to-speech. First, let me introduce our company. So we are a small company with diverse expertise. We have some language technologies expertise. We have developed our own hybrid translation engine for 8 languages, which means 56 language pairs. We have also expertise in cryptography, and we have implemented various high-level APIs on PKCS 11, PKCS 15 for smart cards on mobile devices. We have also developed a virtual smart card solution for Windows, and we have expertise in programming of specialized processors for special devices such as DSP processors, Arduino. We have created an active power filter implementation with the use of specialized DSP processor. And recently we have our share in trying neural networks and their non-trivial C++ implementation. We have implemented neural networks for face recognition and sequence-to-sequence text-to-speech in cross-platform C++. Just a second, excuse me. So we have expertise before neural networks with text-to-speech. We have priorly developed text-to-speech using the Festival and FastVox, and also the C++ implementation, which is Flight. And we were not happy about the quality that we gained. So recently we decided to try neural networks. Generally, the neural networks are implemented in Python. And we have experimented with Tacotron and Tacotron 2. These are the most famous Google models. So we tried the Python implementation with the aim of creating Bulgarian text-to-speech. And our experiments showed that Tacotron proved to be trained much more easily. It has a smaller size and better real-time synthesis factor on CPU-only devices. While Tacotron 2 proved to produce better results. However, its bigger size and low real-time synthesis factor makes it currently inappropriate for implementation on contemporary mobile devices. And next I'll talk a bit about language specifics of Bulgarian. So Bulgarian language is has very close letter to sound implementation. However, there are some specifics. And compared to other languages, sequence-to-sequence neural networks models are trained much easier and better on phoneme sequence rather than on letter sequence. But like I said, Bulgarian has a very close letter-to-phoneme correlation, so we trained our neural network on letter sequences. However, we expanded this a bit because Bulgarian is very stress-prone, so to say. I mean, the stress is extremely important in Bulgarian. Improperly placed stress on one hand can change the meaning, and on the other hand makes the synthesis and sound unnatural. The other thing is lexical expansion, but this is a common task for all text-to-speech synthesis systems. So lexical expansion is important for proper reading of numbers, dates, abbreviations, and others. And as I will continue with training specifics of Tacotron and Tacotron 2, we used Mozilla text-to-speech implementations of Tacotron and Tacotron 2. You can find them at this URL. So at least 12,000 sentences are needed for a well-trained model. And the model can be trained with much smaller corpus. They cannot be trained with a smaller corpus, such as the amount of something like 1,000 sentences. And both models can be modified for multi-speaker training. And we found that multi-speaker training improves the overall quality of each of the resulting voices. So our implementation of the synthesis model is on mobile devices, which has where we had to change the Python implementation and re-implement it in C++. So we decided to use OpenCV4, which has a DNN module. But some of the model layers had to be recoded by us because they were not present in OpenCV, which was quite a challenging task. And our current implementation achieves a real-time factor greater than 1 on multi-core contemporary mobile devices. And on a very, very old single-core mobile device, such Samsung S3, the real-time factor is about 0.4. So the real-time factor means how much time the device needs to synthesize a second of speech. And when the time is greater, then the factor is lower than 1, and vice versa. So in order to get good responsiveness, we had to perform sentence splitting and streaming in order to achieve that, to have low lagging. So when you decide to synthesize something, you won't have to wait for the whole sentence to be synthesized. Just the first part is synthesized, and then it starts to be played. And while playing, the rest of the sentence is synthesized. So we have a market-ready solution, which is our app, which is published on Google Play, and it's called Bulgarian Text-to-Speech. You can find it on this URL. It is implemented as a text-to-speech engine, and other apps can use it to synthesize Bulgarian speech. We have 2 voices, male and female, in one neural network. And it also allows adjustable pitch and speed, and cache synthesizes sentences for faster resynthesis, and uses Google Text-to-Speech for languages other than Bulgarian. This is useful because normally when you have an application that uses text-to-speech, you just set one text-to-speach engine. And if it provides only Bulgarian, it's sometimes not very useful to use it. And all that is in an installation size of only 33 megabytes. Well, of course, our product has some deficiencies, and we have to do our task of lexical expansion better. That's the first. Also, it sometimes does mistakes in stress because of insufficient number of grammar-based stress changing rules. And also our training data sets were not too big, and the models are a little undertrained. So some words may not be pronounced in the best way they could. And I will talk about our challenges and obstacles with our expertise in language technologies. So our main obstacle when developing the text-to-speech was the absence of appropriate data sets. So we had to create them by ourselves, which requires both time and funding. And we think that budget-funded initiatives should produce reusable resources that are hard to create by individual market players. And the use of the resources in market products could be done on give-and-take basis. So each company which wants to use some resource could provide some of their resources to the other players. And I will talk a bit about ELG. So when we created our product, when we started creating it, there were no applicable corpora, sound corpora of single speaker that are used for text-to-speech. And as Svetla showed me, currently ELG provides a number of freely accessible resources that would have been of much use back at the time when we started our project. And currently, OG proves to be a one-stop solution for many tasks requiring large language resources. And that's all. Thank you for your attention. And if you have questions, you can just ask Sveto or me. I'm sorry, I had to put another slide, but
okay.
I missed it.
Thank you, Lucho, for your very interesting presentation.